All right, we're going to look at prime factorization. And basically, prime factorization is I'm just trying to find all the prime factors in a number. So basically, I'm breaking apart a number to find all the prime factors inside of it. Well, to do that, we have to know what a prime number is. A prime number has only two factors, which are 1 and itself. So for example, 2 is prime because there's nothing I can get other than 2 times 1. I can't do any other multiplication to get to 2. 5 is also prime because there's nothing I can multiply other than 5 times 1 to get to 5. And one more example would be 19. 19 is prime. There's nothing I can multiply to get to 19 other than 19 times 1. And a way that I remember this is I always write prime like that with a 1 for the I. So its only factors are 1 and me. It's the product of 1 and me. So it's only two products. The product is 1 times itself. A composite number is the exact opposite. It has more than 2 factors. So an example of that would be 20, because I could do 2 times 10, I could do 4 times 5, I could do 20 times 1. There's a lot of different options. 4 is composite, because I could do 2 times 2, and I could do 4 times 1. And another example is 100. 100's composite. There's a lot of different things I can multiply. 10 times 10, 100 times 1, 20 times 4. There's more than 2 factors. All right, I want you to put a star by this next part. I call these the Fab Five. Most of the time we're doing prime factorization. These are the 5 prime numbers you're going to see most often. Not all the time, but the majority of the time, these are the prime numbers you're going to see. So I want you to memorize them. We've got 2, 3, 5, 7, and 11. Those are the most common prime numbers we have. So when we get to prime factorization and how we do it in just a second, anytime we see one of those numbers, we're going to circle it because it's a prime number. Okay, you might have seen this a little bit in 5th grade, but we're going to try 2 of them right here. We're going to find the prime factorization using a factor tree. So I'm going to do 2 little branches like that. And every time I do a branch, I have to figure out 2 factors of that number. So I need to figure out 2 numbers that multiply to 36. Well, I'm going to do 18 times 2. 18 times 2 gives me 36. And we just mentioned right here, 2 is a part of my Fab 5. So I'm going to circle it. That's an apple on my factor tree. So I'm going to stop. Anytime there's an apple, my branch ends. 18 is still composite because there's more than just 2 numbers that can multiply and give me 18. So I'm going to make another branch under 18. I'm going to keep going until I have nothing but apples left. Well, 18, there's several things I can do, but I could do 9 times 2, just to make it easy. 9 times 2 is 18. We've got 2 again. There's one of our Fab 5, so we're going to circle it and make it an apple. 9, if I think about it, well, 9 I can do 3 times 3, so I'm not done with 9 yet. If we look up here at our Fab 5, 3 is part of the Fab 5, so I'm going to circle both of them. So my prime factorization for 36 would be 2 times 2 times 3 times 3. I have all apples left, so I'm done. An easier way to write that is with exponents. So I have 2 2s, so I can do 2 to the 2nd power times, make sure it's times because all I'm doing right here is multiplying. I also have 2 3s, so I'm going to do 3 to the 2nd power. That's my prime factorization of 36. And a good way to check, 2 times 2 is 4. 4 times 3 is 12. And 12 times 3 is 36. So we know we've got the right numbers. All right, I'm going to do one more with you. I'm going to start my tree. I'm trying to figure out the prime factorization of 50. There's several different ones I could do on this. I'm going to do 5 times 10. It doesn't matter what numbers you pick as long as they multiply to 50. 5 is a part of our Fab 5, so I'm going to circle it. And I'm going to keep going with the 10. And to get 10, I can do 2 times 5. And those are both, on the Fab 5, they're both prime numbers, so I'm going to circle them. Now I have all apples left, so I can write out my prime factorization. I'm going to always write at least to greatest. So I have a 2 times 5 times 5. Or if I wanted to write it using exponents, I only have 1 2, so I don't need to worry about an exponent there, times 5 to the second power, because I have 2 5s. All right, you're going to try these bottom two and then get them checked with me or Mr. Fox.